Okay, so solving trigonometric equations, day 3. Today we're going to be looking at how we can use factoring to solve these. Okay, so first off, before we get started, remember we talked about solving for specific intervals because otherwise we would have an infinite number of solutions every time. So just kind of a reminder that sine has a period of 2 pi, okay, meaning that the values repeat itself every 2 pi. So if we want to find coterminal angles, we add 2 pi. For cosine, once again, it's 2 pi. But for tangent, instead of saying plus 2 pi n like we do for sine and cosine, tangent has a period of pi. All right, it repeats itself every pi units. So example number 1, we factor using a greatest common factor. So in this particular example, notice that we've got cotangent on either side, and normally we would combine like terms. But because this is cotangent of x sine squared of x, these are not like terms and we can't combine them. So what I want to do is I want to go ahead and put both terms on either side. Okay, so my step 1, okay, is to set equal to 0. All right, then we're going to identify the greatest common factor and factor that out. So here I've got a cotangent of x in each. All right, so my second step is I'm going to factor the GCF. And so when I do that, I'm going to cotangent of x out to the outside, right? And then we have 1 minus sine squared of x equals 0, okay? Step 3, we're going to set both factors to 0. All right, we're going to set both factors equal to 0 so I can solve. So we're going to say cotangent of x is equal to 0. 1 minus sine squared x is equal to 0. Okay, and so we're gonna solve. So cotangent of x equal to 0. Remember, cotangent is cotangent right here. This is x divided by y. Okay, so this is just kind of my thought right here. It's x divided by y. In order to get 0, okay, the y value can't be 0 because remember, if you divide by 0, that's undefined. So what we want is 0 divided by some number. It doesn't matter what it is, okay? So essentially what we're looking for here, right, is we are looking for an x value of 0. Where is x equal to 0? Now, notice that we are identifying from pi to 2 pi, right? So basically, we are trying to find all of the values in quadrants 2, in quadrants 3, and quadrant 4. But because it's inclusive, we also have to include pi and 2 pi if it's applicable. All right, so cotangent x, where is x equal to 0? Well, x is equal to 0 at pi over 2 and 3 pi over 2. So here my only answer is going to be 3 pi over 2. All right, because pi is outside of the interval from which we're solving. Okay, here I'm going to solve for this one. We're going to subtract 1. I get negative sine squared of x is equal to negative 1. We divide by negative 1, and I get sine squared of x is equal to 1. We take the square root, and I get sine of x is equal to plus or minus 1. Okay, so where's sine of x equal to 1 or negative 1? Okay, so sine in quadrants 3 and 4, where it is positive in quadrants 1 and 2. Okay, so we know it's not going to be the quadrants 1 and 2. So where is it? X is going to be equal to a negative 1. It's just going to be the 3 pi over 2. All right. So our only answer, our unique answer is x equals 3 pi over 2. Okay, those two values give us the same thing. Okay, so this next one. So first what we're going to do is we're going to get all terms on one side, combine any like terms that we need. So here I've got sine of x's. So we can go ahead and combine these. So I'm going to subtract square root of 2 sine of x minus square root of 2 sine of x. Now, we wouldn't be able to do this if this didn't have a radical 2, right? So this is like, that takes into play the like terms just as the sine of x does. So 2 square root of 2 minus square root of 2 is going to be square root of 2 sine of x. All right, I'm going to bring down the sine of x, secant of x. Okay, bring down the plus, and that's going to be equal to 0. All right, so now identify our GCF. We've got sine of x, we've got sine of x. That's the greatest common factor. All right, it's the greatest thing that both of those have in common. So we're going to factor that out. Say sine of x, pull it out. What do I have left? I have secant of x plus square root of 2 equals 0. Okay, we're going to set both of our factors individually equal to 0. Okay, and we're going to solve for either of them. Now, take into account the interval. It's 0 to pi. All right, 0 to pi is quadrants 1 and quadrants 2 inclusive, though. That means we have to include the 0 or the 2 pi. We have to include pi or negative pi, right? Even though those aren't technically in the quadrants. They're the axes, but we still need to include them because it's inclusive. All right, so sine of x is equal to 0. Where is sine of x equal to 0? Remember, sine is the y value. So where is y value equal to 0? Okay, well, that's at 0 and pi. Okay, secant of x plus square root of 2 is equal to 0. Say secant of x is equal to negative square root of 2. Okay, so remember, this right here, secant of x is equal to negative square root of 2. This is our reciprocal. So this is essentially like we're trying to find cosine of x is equal to negative square root of 2 over 2. Right? That's the reciprocal of this one. Okay, so where is cosine of x equal to negative square root of 2 over 2? Cosine is negative in quadrants 2 and 4, right? So we're only going to be looking for the angle that has a reference angle of pi over 4, okay, in quadrant 2. So that is the 3 pi over 4. Where is cosine negative square root of 2 over 2? Well, it's in quadrants 2 and 4. It's 3 pi and 5 pi over 4, but we're only interested in the quadrant 1 and 2. And so that's the 3 pi over 4. So what is our answer? Our solution set, we've got 0, 3 pi over 4, and pi. Okay, those are all of our solutions there. All right. So the next one, we're going to look at how we can, the next 4, we're going to look at how we can factor it as like a trinomial. Okay, and so what I want to do, so this one we could actually solve it multiple ways, but we're going to look at it from the factoring standpoint. So what I want to do is I'm going to pretend for a second that we don't have the cosine of x, right? I'm going to pretend that this is just 4x squared minus 1 equals 0. How would you factor this? 4 squared minus 1, all right? Well, I recognize that this is a difference of perfect squares, so it's 2x minus 1 and 2x plus 1, okay? This is going to factor the exact same way, right? You're just going to put the cosine of x back into it, all right? So we're going to say 2 cosine of x minus 1 2 cosine of x plus 1 equals 0. Okay, we set both of these equal to 0 to solve. And here we get cosine of x, I add 1, then divide by 2, I get 1/2. Here we subtract 1, divide by 2, I get a negative 1/2. All right, so here we're 0 to 2 pi, all right? Cosine of x is 1/2. Cosine of x is equal to negative 1/2. So because we have the positives and negatives, basically we're looking for that reference angle in all quadrants. We're looking for an angle in quadrant 1, 2, 3, and 4. All right. So based off cosine of x is equal to 1/2, that's going to be our reference angles of pi over 3. All right. So pi over 3 in quadrant 1, 2 pi over 3 in quadrant 2. Okay. And then quadrant 3, cosine of x is equal to negative 1/2 at 4 pi over 3. And in quadrant 4, it's 5 pi over 3. Okay, so these are our answers. You can write it like this, depending on how delta math that, or you can write it in a solution set. Especially when you have multiple answers right here. Sometimes the solution set is nice with the little curly braces. Okay, either way, it all works the same. All right, let's take a look at another one. Okay, so this one, cosine squared of theta plus 5 equals 7 minus cosecant of theta on the interval of 0 to 2 pi. All right, so once again, just like this one up here was already set equal to 0, but just like we did with the GCFs, we want to set everything equal to 0 to determine if there's greatest common factor, to determine how we want to approach our factoring or how we want to approach solving. So These are not like terms because this is squared and this is not. So we're going to have cosecant squared of theta. I'm going to add cosecant of theta. And then when I stack 7, we get a minus 2. Okay. So if the trig values are confusing you in terms of factoring, ignore them. Okay. And just think of this as, or the theta, think of it as x squared plus x minus 2. Okay. How can we factor this? What numbers multiply to get a negative 2 and add to get 1? It's x plus 2, x minus 1. Right? These multiply to get negative 2, add to get a positive 1. All right, so now once you've factored it like this, you're just going to put the cosecants back in there. So cosecant of x plus 2, cosecant of, I guess we're going to theta. We'll use theta. Cosecant of theta minus 1. Okay. We set equal to 0. We set them, both of the factors equal to 0. I solve. So where is cosecant of theta equal to negative 2? Okay. Cosecant of theta equals negative 2. This is a reciprocal function. So remember, this is essentially like we're trying to find sine of theta is equal to a negative 1/2, right? Thinking about our positives and negatives. All students take calculus, right? Where is sine negative? Sine is negative in quadrant 3 and 4. So we need to find where sine is equal to 1/2, right? So that's a reference angle of pi over 6, right? So in quadrant 3, that means it's 7 pi over 6. And in quadrant 4, it's 11 pi over 6. Right? And then we need to find cosecant theta is equal to 1, right? So remember, this is the same as sine of theta. The reciprocal of 1 is just 1. Where's sine of theta equal to 1? Keep doing that. Theta is equal to, sine of theta is equal to 1 at pi over 2. Right, so what are our solutions? We have pi over 2, pi over 6, and 11 pi over 6. Okay, we've got those 3 solutions there. All right, just a couple more, just to kind of give you some extra practice with the factoring on these as well. All right. So we have 2 sine squared of x plus 3 sine of x minus 2 equals 0. 0 to 2 pi, all right? So we can solve these and just think of the normal unit circle. So if it helps you factor, we're going to say 2 of x squared plus 3 of x minus 2. All right. So when I factor, you guys may use a bunch of different methods. You may use the slide and divide. You may use the AC method or the split the middle term, whatever means you want to factor. I just like to use my guess and check, where I split the first term as 2x and x. I split the second term. I know to get a 3 that I'm going to need a 4 and a 1. So I have positive 4, negative 1. So I get my factors right here. Okay, so then we're just going to, wherever we have the x's, we're going to put the signs in. Okay, so we have 2 sine of x minus 1 and sine of x plus 2 equals 0. We set them both equal to 0. All right, I solve. Add 1, divide by 2. Sine of x is equal to negative 2. All right. Okay, so for this one, where is sine of x equal to 1/2? Okay, well, sine of x is equal to 1/2. And it's positive. Okay, so our solutions are going to be in quadrants 1 and 2. And 1/2 gives us a reference angle of pi over 6. So x is pi over 6 and 5 pi over 6. Okay. For this one, it says sine of x is equal to negative 2. Okay. If you remember on the graphs, you remember how the graphs, the output values, they never go over or under 1. So in this case, if you get a number that is greater than negative or greater than 1 or less than negative 1, it's not going to give you a value, right? It's not going to give you an output. Even if you want to just try to get the decimal and try to evaluate it that way, once again, it's still not going to give you a value. See, watch what happens when I put this into my calculator. Sine of x equals -2. Do sine inverse. Oh, hold on just a second. I can put. It gives me an error. Okay, that's because -2 is not in the domain, or -2 is not in range of that function. So this isn't possible. So this one, it's undefined. So our only two possible solutions are pi/6 and 5 pi/6. Okay. All right. One more problem here. I've got secant to the fourth x minus 4 secant squared of x plus 3 equals secant squared of x minus 1. So the first thing I want to do is I want to set it equal to 0. Then we'll worry about the fourth power here. Okay, so subtract secant and add 1. That's minus 5. Secant of x plus 4 equals 0. So what we want to think about right here, okay? Think about factoring x to the fourth minus 5x squared plus 4. Okay, now this isn't a quadratic, but it's called quadratic form because it factors very similarly. Okay, so when I put out my parentheses to factor, x fourth, I know can split up to x squared and x squared. And so then we're gonna follow the exact same approach here. So I'm gonna put a minus 4, minus 1, because multiply to get positive 4 and add to get -5. So it works the exact same way. We're gonna say secant squared of x minus 1 and secant squared of x minus 4. Okay, we're going to set them both equal to 0. And solve. So for this one, we get secant squared of x is equal to 1. We take the square root. So secant of x is equal to plus or minus 1. Here we get secant of x is equal to 4. We take the square root, and I get secant of x is equal to plus or minus 2. Okay, now, keep in mind, this case, we're going from pi to 2 pi, so we're only focusing on the third and the fourth quadrant. All right, so secant of x is equal to -1. So remember, in essence, what we're looking for here is we're looking for cosine of x is equal to, okay, because it's cosine, we're only really worried about quadrant 3, all right, where it's negative, so the reciprocal of 1 is 1. Secant, we're looking for, same thing, yeah, cosine of x is equal to the -1/2. Right? That's essentially what we're looking for when we talk about the reciprocals. So here I'm going to say x is equal to, where is -1? Cosine is -1 at pi. Okay. Here, where is cosine -1/2? Cosine is -1/2 at the 4 pi over 3. Right? And so those are our two answers. Okay.